The cosmos moves fast and uniquely, and mankind makes daily progress in its comprehension of the world around us. Since the creation of space technology like the James Webb Space Telescope by the U.S. National Aeronautics and Space Administration or NASA, space exploration has gotten significantly easier. It is capable of seeing objects as far away as the center of the Milky Way Galaxy because of its superb infrared resolution technology and high sensitivity. Unexpectedly, the JWST discovered a massive structure while studying the components of the Milky Way Galaxy, and this huge structure is older than the universe itself. This has the scientists in amazement. What is this massive building? What effects will this revelation have on cosmological research as we presently understand it? And what steps will scientists take as a result? One of NASA's biggest accomplishments is the James Webb Space Telescope, originally known as the Next Generation Space Telescope. The multi-billion-dollar telescope was dedicated in September 2002 in memory of James E. Webb, who directed the Mercury, Apollo, and Gemini programs while serving as NASA administrator from 1961 to 1968. Cosmologists' perspectives and how they view the entire solar system have been revolutionized by the James Webb Space Telescope, which has proven to be a fantastic invention. The main purpose of this stunning invention, which is now the largest optical telescope in orbit, was to observe and investigate astronomical objects in space using infrared light. On December 25, 2021, an Ariane 5 rocket was used to launch the James Webb Orbit Telescope into orbit from the European Spaceport in French Guiana. The space telescopes were designed and constructed by the Canadian Space Agency or CSA and the European Space Agency or ESA. For the $10 billion project, Northrop Grumman was the principal contractor. The James Webb Space Telescope has to be kept at a very low temperature of -223 degrees Celsius to continue working. This is required to prevent the infrared light from the telescope from obstructing the ambient light. With 5 fewer sunshields shielding it from the Earth's moon and the sun's warming effects, this extraordinary gadget is positioned in solar orbit close to the L2 or the Lagrange point, 1.5 million kilometers from Earth. A few weeks later, on January 24, 2022, the mission team accomplished a critical step by activating Webb's thrusters to launch the space telescope into its targeted orbit around the Sun and the second Lagrange point, a great distance of nearly 1 million miles from Earth. The location of the James Webb Space Telescope gives us a perfect and broad view of the cosmos, while also enabling the scientific instruments and optics to stay in a cool enough environment for this great technology to function and carry out regular science as it was intended. This space technology's initial trip also broke a record. The first deep field of the space telescope is the sharpest and most detailed infrared image of the far-off universe ever taken. One of the largest and faintest lit objects ever seen in the infrared is seen in the image, Galaxy Cluster SMACS 0723. The next day, July 12, 2022, further images taken by Webb's cutting-edge scientific apparatus were made public to show the telescope's progress. Stephan's Quintet, WASP 96b Spectrum, Southern Ring Nebula, and Carina Nebula are the objects in question. Recent findings have given rise to a brand new cosmic creation story. A stellar nursery, precisely 30 Doradus, is the location where hundreds of brand new stars that have never been observed before are found and captured on camera. Because of the appearance of their wispy filaments in previous telescopic images, NASA's James Webb Space Telescope gave these young stars the moniker Tarantula Nebula. It has long been a tradition to study the Tarantula Nebula when studying star formation. The James Webb Space Telescope also showed distant background galaxies in the intricate structure and makeup of the nebulous gas and dust, which provided support for the forming stars. The largest and brightest star-forming region in the neighborhood is the Tarantula Nebula. The galaxy closest to our Milky Way is the Large Magellanic Cloud, which is 161,000 light-years away and contains the most massive and hotter stars known. As a result, the Tarantula was the focal point of 3 of the James Webb Space Telescope's high-resolution infrared sensors. When seen using the near-infrared camera of the Space Telescope, the region resembles the home of a burrowing tarantula. Looking at the neighboring camera image, one can see that the cavity of the nebula has been filled with powerful radiation from a cluster of huge young stars that shines in a pale blue color. Recently, our galaxy was discovered to contain a giant filament of atomic hydrogen gas by a multinational team of astronomers under the direction of the Max Planck Institute of Astronomy, or MPIA. One of the longest formations ever seen in our galaxy, dubbed Maggie, is situated around 55,000 light-years away, on the other side of the Milky Way. Jonas Said, a PhD candidate at the MPIA, was the study's principal investigator. It was just published in the journal Astronomy and Astrophysics. Researchers from the University of Calgary, the Universitat Heidelberg, the Center of Astrophysics and Planetary Science, the Argelander Institute for Astronomy, the Indian Institute of Science, and NASA's Jet Propulsion Laboratory joined him. They were also joined by researchers from the University of Vienna, the Harvard-Smithsonian Center of Astrophysics, or CFA, the Max Planck Institute for Radio Astronomy, or MPIFR, and the University of Calgary, or JPL. The study is based on data from the Carl G. Jansky Very Large Array, or VLA, in New Mexico's HIOH Recombination Line Survey of the Milky Way, or Thor, an observing program. This project investigates molecular cloud formation, the conversion of atomic to molecular hydrogen, the magnetic field of the galaxy, and other issues concerning the ISM and star formation using the centimeter wave radio dishes of the VLA. The overarching goal is to understand how the two most prevalent forms of hydrogen gas combine to form thick clouds that give birth to young stars. Atomic hydrogen, which consists of one proton, one electron and no neutrons, and molecular hydrogen, or H2, which consists of two hydrogen atoms bound together by a covalent link, are the two forms of hydrogen. Only the latter condenses into somewhat small clouds that eventually give rise to icy areas from which new stars can eventually form. This exceptionally long filament was particularly fascinating since it provided new information about the process by which atomic hydrogen transforms into molecular hydrogen. The erosion caused by the stellar winds from these stars can only be withstood by the nebula's highly populated surrounds, resulting in pillars that appear to face the cluster. There are forming protostars in these pillars, which will someday emerge from their dusty cocoons and alternately reshape the nebula. The Webb Space Telescope discovered a very young star performing the same action as it was circling and watching into space, even though the close speck displayed on the star was only just starting to emerge from its pillar. The dust cloud that was now encircling it was still present. Without it, the star formation process would not have been visible. Anytime brilliant stars and cooler gas are found by the mid-infrared detectors of the Space Observatory, it is safe to assume that the region is observable at longer infrared wavelengths. In such cases, the area seems completely different. Shorter light wavelengths are either absorbed or scattered by the nebulous dust particles as trapped protostars grow in mass. Stellar nursery clouds' points of light start to become apparent. The previously unseen cosmic environment may now be seen because longer mid-infrared wavelengths can now pass through the dust, blocking Webb from being seen. In great part due to the Tarantula Nebula's existence of a certain type of chemical substance, astronomers are drawn to it. This chemical composition is consistent with the sizable star-forming region that was found on the universe's cosmic moon when it was barely 1 billion years old. The development of stars was at its pinnacle. The star-forming regions in our Milky Way Galaxy do not generate stars at the same alarming rate as the Tarantula Nebula because they don't have the same chemical composition. Due to its singularity, the Tarantula Nebula is the best example of what is happening in the universe. The perfect opportunity to research and compare views of the star formation in the Tarantula Nebula would be made available by the James Webb Space Telescope. The brilliant invention is just starting its mission to rewrite the story and history of stellar creation, despite several human attempts and a great deal of time spent watching. This is due to humans' inability to take crisp, precise photographs. All of this was occurring in the background of a large cloud of star nurseries. However, as the greatest optical telescope in the universe, the James Webb Space Telescope is here to put on a show. It only requires us to relax, take a seat, and listen as it exposes the universe's many mysteries. What then do you think about the huge structure which is older than the universe? Let's know your thoughts in the comment box below, and don't forget to subscribe to our channel for more exciting content. Thanks for watching.